The next probability sample that we'll learn about is the cluster sample. And that's when the population is divided into several clusters, each representative of the population. And a simple random sample of clusters is selected. So all the items in the selected clusters can be used, or items can be chosen from a cluster using another probability sampling technique. The cluster sample is really used as a cost-effective measure. So for example, if I am the governor of Texas and I want to know how many elementary schoolers are on the assisted lunch program, instead of doing a simplified random sample of all elementary schoolers in the state of Texas, which can be quite time consuming to collect, what I would do is I would divide the population in my population into clusters, so maybe the counties, and randomly pick a county. And from that county, I am going to sample all the schools in that county to see how many students are on and the assisted lunch program. So that would be an example of a cluster sample. Here's another example of a cluster sample. If I wanted to know students' views on RAs, here I have 11 different residential student resident halls. And so a cluster sample would be I'd randomly pick one of these halls, throw it in a hat, pick out one. I pick Founders Hall, and I will survey everyone in Founders Hall about their views on the resident assistants. So again, with cluster samples, you are dividing up the population into certain clusters, or there are clusters that already exist, and you're randomly picking everyone in that cluster. So simple random sample and systematic sample, they're very simple to use, but they may not be a good representation of the population's underlying characteristics. A stratified sample ensures representation of individuals across the entire population, and the cluster sample is the more cost-effective sampling technique. So the different types of errors that one can encounter with sampling, you could have a coverage error, which can result in a selection bias. So we were talking a little bit about this with the sampling frame. If some groups are excluded from the frame and have no chance of being selected, then this results in a coverage error and a selection bias. You are purposely selecting or excluding people from the sampling frame, which could change your results in the end. A non-response error or bias. People who do not respond may be different from those who do respond. So I'm sure you've gotten the phone calls in the middle of dinner from telemarketers asking if you'd like to take a short survey. Now, are the people who agree to take those surveys, are those people inherently different from those who do take it? That would be a non-response error. A measurement error would be due to weaknesses in question design or respondent error. We'll come back to sampling error in just a minute. But here are some examples of measurement error that might occur. So when you're designing a survey, you might want to think about the wording that you use. So for example, if I wanted to know what percentage of Americans think the U.S. government spends too much money on assistance to the poor, I might get different answers if I ask this question instead of that prior one. So what percentage of Americans think that the U.S. government spends too much money on welfare? Now, because of the terminology that we've used in these questions, we can get very different answers, and that would result in a measurement error. Here's another example of measurement error. In a typical week, on how many occasions do you have at least 2 drinks in one sitting? If I give you the first options in this second bullet point, never 1 week, twice a week, 3 times a week, or 4 times a week, a lot of people are probably not going to pick 4 times a week because they think, well, that's extreme. I'm not an extreme drinker, so I'm not going to pick that one. However, if I were to give a different set of options here, so never 1 to 2 times a week, 2 to 3, or 4 to 6, or 7 times a week, we're likely going to see more people pick that 4 to 6 per week than we did in the prior options, because 4 to 6 is now not an extreme option, so they're more likely to choose it. So again, how you word your questions can really impact your results. So and then the last type of error is sampling error. And for probability samples, sampling error will always exist. Now, this is because there is some variation from one sample to the next. So going back to our flu example, if I take a sample from Houston, New York, and Chicago, it might be slightly different than if I took a sample from Houston, New York, and Denver. So because samples will always vary from one to the next, sampling error will always exist. And well-designed studies do their best to try to reduce errors such as measurement error, coverage error. Non-response error is a little bit harder to control, especially if you're doing a voluntary survey. But well-designed studies really try to reduce these types of errors. So in this chapter, we've discussed the types of variables using statistics, how to collect data, different ways to collect a sample, and the types of survey errors. And here's a little practice here. I want to know the average amount of student loans WT students take out every year. Identify the population of interest. Money is considered a blank variable. If I chose to survey only freshmen, this would result in blank and blank. I decide to randomly choose 100 students in the College of Business, 100 students in the College of Nursing and Health Sciences, and 100 students in the School of Engineering, Computer Science, and Math. This would be considered a blank sample. If I randomly chose a major and survey all students in that major, this would be considered a blank sample. So take some time. So identify the population of interest. Our population of interest are WT students. Money is considered a numerical discrete variable. If I chose to survey only freshmen, this would result in coverage error and selection bias. I decided to randomly choose 100 students from each of these colleges. This would be considered a stratified sample. If I randomly choose a major and survey all students in that major, this would be considered a cluster sample.